Yes, students, we're continuing the overview of C programming we started. So in this session, we're actually going to complete that overview today. Just to do a small recap of where we stopped last time, we look at control flow, specifically the if construct, which is available in the C programming language. So we've seen some examples, and you would definitely use the control flow, the if statement a lot during the programming. So at the end of the last video, I asked you to start considering these programs. So the first one is to write a C program to determine the grade given the mark for a given module. So you can take your own grading system. If you get above 80, it's an A plus. If you get between 70 and 80, you get an A, and so on. So you can now request a mark from for a given module from a student, from the user, and then you can just print on the screen what is a grade. So this is that program. The second one is saying write a C program using the else if statements and other syntax we have covered till now to solve a user-defined quadratic equation. So we've considered the solution of a quadratic equation right at the start of this module, where we were discussing the way you can depict a program using flowcharts as well as pseudocode. So we've actually covered this program already in its syntax, in its algorithm. So now it's the opportunity for you now to start coding it, because you have all the necessary tools using a scanf, printf, if, and you also have the math.h tool, the math.h header file, which contains mathematical functions if you need to do any square root, or you need to raise, you need to calculate the power of any term. So you are able to write this program now, so give it a try. Now, the third program is to write a C program to calculate the area and volume applicable of the following geometries. So you can calculate a circle, rectangle, or any of the shapes you want to add here. But the point is, you need to ask the user, you need to provide a key to the user to ask him then which geometry he wants to consider. And then based on that input from the user, from the choice of the user, you need to provide specific messages to the user to request the required information. For example, if you are asking if you want to calculate the area of a circle, for example, a circle will not have volume, so you would request a diameter or the radius from the user. If the user wants to deal with rectangle, we know here we don't again have a volume, but we have an area, and you need to ask the length and width and so on. For example, if the user wants to calculate the parameters for cylinder, then you would need to request the radius and the height, and here you can calculate an area and volume. So using if else if statements, you're able to first get the user you can first of course request a user to give his choice, and then based on this choice you can now the if else if construct to decide what are you actually going to ask the user. Yeah, so give this program as well a try. Now let's consider symbolic constants. So in your program, for example, the program you've just worked on, you most likely would have used pi, and you can put the value of pi as 3.142 or any or more decimal places in the program, but you can use now symbolic constant to actually use constants to represent these parameters. For example, if you have in your own field in mechanical engineering, you have constants like Young modulus or Poisson ratio, and you have lots of similar constants in physics or in your subject you come across. So these constants definitely won't change over the course of your program. You can save them as symbolic constants. So let's see how it's done. So the syntax to actually define a symbolic constants as follows: you use a hash define result keyword, and then the name of your symbolic constant, and then what you actually want to replace it by. So basically what you are doing when you are creating a symbolic constant, you're just replacing a text or a figure or a name using a given variable name, which is going to be constant. Now typically this name here is going to be in uppercase. Yep. So if you look at this program here, which is a program we've seen already to convert from Fahrenheit to a degree Celsius, remember, and then we had this lower, upper, and step which we are defining in the program. But here we are defining this free as constants, as symbolic constants. So as we have seen, you use a hash define. Then the lower here is a name, and 0 is what text or number we have to use to replace lower. So in your program, wherever you have lower, the compiler will simply replace it by 0. Similarly for upper, where you have upper, it's going to replace it by 300. And wherever you have step in your program, it's going to replace it by 20. So as you can see here, instead of using 0, 320, your program become more readable now, because finding terms like lower, upper, and step is much more intuitive than just putting figures there. Okay, so quite simple here. So you can use the symbolic constants to define terms like pi or your modulus and so on in your program, and you typically define that, as you can see here, above main. So all these constants will be available throughout your code. And again, as you can see, we are using uppercase letters to define the symbolic constants. It's not a requirement, but it's a good practice. So wherever we find uppercase names like this, they're not variables because their values don't change in the program. So they're symbolic constants. So it's a way for us to differentiate between symbolic constants and variables. For example, here FHR is definitely a variable because value changes. So if you look at this line here, FHR is lowercase. So we know just by looking at the variable name that this is actually a variable and this one is a symbolic constant. So this is just a good programming practice. So we've already covered the for loop. So in the previous video, I've shown also examples how the for loop works. It's actually analogous to the while loop as we've seen, but the three requirements for while loop, which we've discussed, initialization, checking, and update, are all the same place. Yep, so this is what's illustrated here. So if you look at this one, just to do a small recap of what we did in the previous video. So this is the initialization one, because you need to initialize your term, which you want to do a checking here. Yep, so initialization, checking, and update, but all these expressions are here on one place in the for loop. So it's the initialization part, and then the checking part, and then the update is here. Okay, so we'll use a for loop later today when we start discussing arrays. It's used commonly with arrays, but of course you can use a while loop as well with an app. As you see, they are analogous. Therefore, the for loop is a more compact way of running a set of statements because all three are together. Now, I think when we were discussing in last week's practical, we did have I did give you this problem to think about, this challenge to think about, to write a for loop to print numbers 1 to 100, showing 10 numbers in a line, and you can use a modular division operator to change the line after you print it every 10. So again, do work this out, do try this code on your own, and we can discuss next time. Okay, so that's fine. You see, use the for loop in the previous program. You can remember that this program actually we also write using the while loop. The very first time we look at this conversion of Fibonacci code, we were using a while loop, but you can very well use for loop as well to do that. Now, what this next is considered the switch statement. The switch statement is actually a control flow. We've considered the if statement before to actually decide how your program can take decision based on certain conditions, but another way you can do that using the switch statement. So let's see how it works. How the switch statement works. So typically here, the switch is going to be on a particular expression here, which is going to take different values. And based on the values this expression is going to take, which is typically an integer or a character variable. So based on the value this takes, if it takes this value here, like say case constant expression, is going to do a series of statements. If it takes another value, it's going to take other statements. And the default here is similar to else you have. So in your if nothing works in your if, then you always have an else, which would take up any other condition. Of course, else is not mandatory, so it depends if you want to have it or not. But here the default is analogous to that else. Yep. So it becomes clearer when we look at one example. So let's look at this example, and then we'll come back to slide. So the program starts here by defining in a variable I of integer type, and we're assigning to 2. And let's see how this works now. As you switch I, so depending on the value what I is taking, is going to do either, if it's 1, it's going to do this one, if it's 2, it's going to do this one, if it's 3, it's going to do this one, and so on. So you can see now there's a keyword called break. Now the break simply says whenever you get that case, you don't check for the other cases, you just go out and continue the code. So if we just go back again to the syntax here, in this case, expression here is actually a variable in this case, so I. And then here, of course, we are setting the value of I to 2, but this could be dynamic here in the sense that this value of I could be requested from the user. For example, remember when we considered earlier program to calculate the geometry the parameters of different geometries, it could be circle and so on. So you could now have a variable called choice, and then you request this value from the user, and then based on the value which the user input, you could use a switch construct here to actually put all the different possibilities. So case one, for example, could be circle, case two could be rectangle, case three could be parallelogram, and so on. This, of course, the same could be done using the if construct, but the switch as can say give you cases. Yep. So case one, case two, case three, case four. Now, of course, you can put a comment here to say what is case one, what is case two. Now, the expression which you have in the switch statement can be an integer, as you can see here. It can also be character. So you could also request a user for characters. So in this case here, we are using ch in the expression for switch, and ch is a character type. So it would be typically single characters as we've seen earlier, so A, B, C, D. And here, if we put ch is going to B, so it's this case which is going to run, so it's going to print case B. And then again, you have a break. So whenever this a particular case is actually relevant, then it's not going to run the remaining. Now you have a default, as I said earlier. So if you input, for example, a character for ch, you put A, for example, here, and then there's no case for A, then nothing's going to run. So it will run this default state. Okay. So useful, it depends if you want to use it or use it if else. The switch statement is analogous to the if, just to do a small recap. It allows you to structure your program very well using cases. So you have this keyword here called case. So case one, case two, these are the values taken by I. And for each case now, you can structure your code very well. So you can see a switch has an opening curly brace and a closing curly brace, as we've seen earlier, sort of group all this in the same under switch. Okay, so you can just practice these codes there and see how it works. And I would encourage you then to apply this in this program we've seen earlier here for different geometries. So this one here, the third program here, we have different geometries. So you could request the user for particular input. For example, you can also you can give a key to a user, and if the user inputs 1, then it means he wants to deal with a circle. If he inputs a 2, it's a rectangle, 3 for square, 4 for parallelogram, 5 for cylinder, 6 for sphere, and 7 for prism. And then now you request for scanf the user which choice he wants to have. If, for example, he inputs 6, then you list a sphere. Then in your case there, you know that case 6 would be request the radius of a sphere and then calculate the area, the curved surface area, and then the volume, and then print that in that particular case. Yeah. So I would encourage you to do this code, and we can again discuss that when we meet for the lab session. So we consider the switch now. So a last topic we discussed for today is arrays. Very important chapter in C programming or arrays. So an array allows you to hold a given number of values of the same type. For example, now we're defining a variable, let's say int a can store only one value. But what if you wanted to store several numbers in the same variable? So this is then using an array. For example, in your class, if you wanted to store the marks of all students, all 28 students in your class, the marks for Mac 2107, so you could use an array to store all these numbers and be able to relate to them using indexes. Okay. Let's see how we declare an array and then how we actually store values into them. So this array here, this code there, so it's familiar to us. Float, it means the variable we're defining can store decimal point numbers. So again, we have this consideration to decide on the correct data type. And now this is what's new here. We have this square brackets there, and then we put a number inside, which is telling to us that marks is actually an array which can store decimal point numbers, and it can store 40 numbers. Okay, that's what this 40 means. So when you're declaring an array, you typically would set the maximum limit for the number of terms that you want to store in that particular array, but you don't need to use all of them. Yeah, for example, if you're using this marks 40 there, but you have only 28 students in your class, so you can very well use the first 28 placeholders for storing data. The remaining can remain empty. Now, important in C programming is the way you can now read values or store values in this array. The index there would start always at 0. In C programming, the index for an array always start at 0. So since, for example, here we have 40 terms, 40 numbers which you can store in this array. Since the index starts at 0, the last index will be 39. So you should never here actually use marks 40 to store a number or to retrieve a number because it's out of the range of an array. So when you're declaring it, of course, you put 40 here just to say that you have 40 numbers, 40 terms if you want to store in the array. But when you start using the array through an index there, so mark 0 is the first index, first element of the array, marks 1 is the second one, and so on. So in this way, it means the last term will be marked 39 if you use 40 as a number of terms. Now, since we know now how to declare an array, and you have used the for loop before, so now it means, for example, if you have an index I, if you write a for loop with an index I starting at 0 and then you got 39, you can very well now store numbers in the array using scanf, and you can also read values from the array using printf or any computation you want to do. So based on that here, the first program I'm asking you to write is write a program in C to request for 10 numbers from the user and sort the numbers in ascending order using an array to store the numbers. So the program is going to first request 10 numbers from the user, and this is a new part now. You have to see how are you going to sort the numbers in ascending order. Means you want to start with the smallest one and going to the largest one. So this is a new piece of code there, a new algorithm which I want you to think about. So first thing you need to be able to do is first be able to store the 10 numbers in the array. So again, if you have 10 numbers, it means it's going to start from 0 and the index will end at 9. So you have to use scanf and a request for these 10 numbers. It would typically be the for loop, which is going to run 10 times. Once you have these numbers, then you can do sorting. Okay, that's the first program. Second program now is very similar, but we don't want to fix the number of terms to 10. We want the user to set, but again, like I've said earlier, you need to tell the user to put an upper bound. For example, you can see the maximum number of numbers the user can input is, for example, 100. Yeah, and then he can put 50 or 25 depending on his requirement, but you won't exceed that, and this 100 would now be used to actually declare the array. And then the similar we've done, you're going to ask the user for these numbers, and the new algorithm now is once you have these numbers, I want you to calculate this mean and standard deviation of this set of numbers. Okay, now to give you a bit more information how arrays actually, how we use arrays. So this line here is declaring an array called balance. It has 5 elements and we're already initializing it. So here we use the curly braces if you want to do that. So we've seen earlier when you are declaring a variable, you can also set a value immediately to it. If I just go back on the program, we look with switch here. You can see here, we are actually declaring it and defining at the same time. So if you want to do that for an array, this is the syntax to do it. So as you can see here, we are saying this has 5 elements and these are the 5 elements. So this is first element, second, third, fourth, fifth, and this is declaration and assignment or definition at the same time. Now these two lines are equivalent. It's omitting the 5 here because the compiler can actually find that you have 5 elements because this is what you're putting. So you can leave the number of times in the declaration for the array when you're actually defining it. But if you were defining it here, you would need to put the number. Okay. Now, to extend further now the concept of arrays, we have 2D arrays. So what you've seen till now is a 1D array, which is like a vector. Yeah, so it's only one dimension. Now, if you add a second square bracket, it means now you have a 2 dimension and it becomes like a table. Yep, a table. So the first index here, as you can see, correspond to the rows. Yep, so 0, 1, 2, and then this index here correspond to columns. Yep. So for example, this is 0, 0, 0, 1, 0, 2, and 0, 3. These are all zeros here because this is row 0, this is row 1, and this is row 2. So if you need to use a 2D array now for any specific reason, for example, if you're dealing with images with pixels, typically it's going to be an array. So for any specific reason, if you want to use the data in a tabular form, you can use 2D arrays in a very similar way here. Now you have 2 indexes. So X is going to be the first index, and then Y is the second index. The index X corresponds to rows, and index Y to the columns, as we've seen. And X and Y, of course, have to be integers, yeah, because they are column numbers and row numbers. Now, if you have a 2D array, you would typically use 2 for loops, 2 nested for loops. The first for loop is going to deal with a row, and the second one with a column. And this is how we typically would initialize a 2D array. So here you have a first curly brace, a second curly brace, and then each one now the inner curly brace. So this one is going to correspond. So if you look at this declaration here, we have 3 rows. So these are your 3 rows, and then your 4 columns. These are your 4 columns. So this first element there is going to be the first row, and then the second one is the second row, and the third one, the third row, and each row would have 4 terms because you have 4 here. So you can easily show that in table form if that helps you. Now, this piece of code illustrates further how you actually access the elements in your array. Yep. So you're using I and j here for your indexes. So you can see here you start with I0 and I less than 5, I plus plus. So this one is allowing you to actually scan through your array. So this is how we've declared and defined a 2D array. And this line, these 2 for loops here, these 2 nested for loops allow you to scan through your array. So this one are the rows, and the row is from 0 to 4. This is why I have less than, we don't put equal to, else we're going to go out of bound. And this one, we say we have 2 columns. This is why starting at 0 and ending at 1. So your columns going to be 0 and 1 only. So this program is actually printing the terms of your 2D array. Give it a try. This is a bit more advanced, like we're saying. You can do a similar thing here for a 1D array. So you have only 1 for loop, and you can scan through the loop to actually store numbers using scanf in there, or you can retrieve data, like we said, using printf, or for doing addition or any other operation you need to do on your array. So I'm stopping here for this overview of C programming, and we've completed all the elementary features I wanted to present so that you're able to start coding. Subsequent chapters, we go in depth now of this concept, and now you are well equipped to be able to start writing programs. So I'm ending here. Do try the programs I've highlighted through this session today, and we discuss any problem you have in the lab session. Thank you.